Next, we're going to talk about another distribution called the F distribution. And this is going to be useful when we have two populations and we want to compare variances from those two populations. So these subscripts here are indicating two different populations. So if I want to do a hypothesis test where I'm comparing two variances, maybe something like this to something like this. If I want to do a hypothesis test like this, then I want to use the F distribution. So I want to use chi-squared if I'm doing hypothesis testing with a single variance, but when I'm comparing variances from two populations, I'm going to use this F distribution. And on the left here in the notes, you can see that this distribution is also not symmetric. It kind of looks a little bit like the chi-squared distribution. And if I make these degrees of freedom bigger, note that there are 2 degrees of freedom because I have two populations. So if I make df1 bigger, it looks like this is also getting more symmetric, but it's not moving to the right like chi-squared did. It's getting more symmetric and kind of getting steeper over on the left there. And so the F distribution curves, they are also not symmetric. They're positively skewed or right skewed. And as degrees of freedom increase, it looks like the skewness decreases, like it did with chi-squared. And since this is a probability distribution, the area under the curve is equal to 1. And again, all values of the F distribution are greater than or equal to 0. We don't have any negative values. And again, you can use tables to find these, but as usual, we're going to use Excel. And so we're going to do f.inv.rt to find these critical values. And we are going to set up our hypothesis tests to be right tail tests when we do this. And so we're going to want to use this right tail option. And in exercise 2 here, you can practice finding some of these critical values. And so in part A, it's giving you the alpha and the 2 degrees of freedom. So to find the critical value, it's telling you that we have an area of 0.10 to the right, that's our alpha, and it's telling us that degrees of freedom 1 is 12 and degrees of freedom 2 is 20. And the order does matter here. And so to find that critical value, that critical F value, we would do f.inv.rt of that alpha, and then we would plug in our degrees of freedom, the first one, and then the second one. And that's how we would get that F value. So feel free to try that with these other problems here.